Hello everyone, this is the introductory video for Learning with Augmented Reality 2.0. This project is meant to be used by the School of Architecture students in order for them to learn how the CPA building was modeled. When we first got to our product owner, we have some problems to tackle. The first one was how to make students learn when using this application. The second one was how to implement different behaviors of the Scope AR application depending on the user interaction. And the third one was how to create a user-compliant Scope AR application for Android or iOS deployment. We didn't use the previous version because it has our product owner didn't want to follow the same steps that the previous team was tackling, so we took a new approach based on our product owner needs. In order to tackle these problems, the main user stories implemented were Scope AR UI navigation. The main purpose of this user story is for users to navigate through the application from one panel to the other. Then we have to implement the Scope AR state machine for the user interface. So we wanted the application to behave differently depending on where the user is in the application. Next, we did the setting up cameras, which was the user story handling all the setting of the cameras, which is the AR camera, background camera, and interface camera. And then we uploaded the application for user story 191 is in charge of setting up the descriptions and images for each panel, which is where the learning comes. When a student reads the description, it helps them understand what the part is for. Afterwards, we uploaded the application for the iOS platform. And finally, we implemented the movie player. This use case diagram basically describes all our user stories. The first one is interact with AR camera. This interaction also encapsulates the calibrate the AR camera. If you wanted to calibrate the model, we can toggle the AR camera if we want the model to stand still or keep moving. Then we wanted for student to see the background camera, and we can also toggle this background camera. The student can also interact with the interface, can navigate through panels, which was one of the first user story we implemented. And then if a student clicks an expand icon, it can either play a movie or view a diagram and description. And the last one was if a student touches a structure button, it should be able to see a diagram as well and a description. So our minimal class, we have first the interface, and then these alpha state, beta state, icon state AR, and main state AR, which implement this interface. Later on, we have the state pattern AR, which is the actual class that handles the moving from one state to the other, depending on where the user is in the application. And then we have that, well, we know from the diagram that the alpha state, beta state, and icon state AR, they use this description class, which is the one that sets the description for the panel or icon. And then we have these three classes: the gyro camera, which is the one that actually takes the data from the gyroscope of the device and then sets that data to the camera, so the model looks like it's moving. And then we have the movie texture player, which is the one that plays the video. And then we have the VG-Cam script, which is the script that actually takes the input of the camera and then sets it to the background of the application. For the description class, we use a singleton pattern because we only want one instance at a time of the description. So every time icon state, better state, alpha state call, it will get only the one instance of the description class. So this is the state machine we use for our application. We have our main state, which is when the application starts. Then we can go either to alpha state or beta state. These two states represent the 2 points that can be chosen in the application. So far we have implemented only 1 point, although we have implemented already the beta state in the code. So from the alpha state we can go to the icon state and then go back again. The icon state AR is when you click an icon and then you can either go to see a diagram, or you can also go to see the movie of that part. Same happens here. When you go to the beta state, you can go to the icon state and then go back to. So these are two of the main algorithms that are being used in the view and set descriptions. The first algorithm is called populate dictionary. This algorithm, as soon as the application starts, it reads from the tile description text file. It's going to be reading all the lines, and then the lines are built with a name, equals, and then a description. So in the dictionary, it's going to be inserted the name and the description until the end of file. The second algorithm is named setDescription, in which the application first gets the current platform. It can either be iOS operating system or Android, or the application is basically running on Unity. So depending on what application on what platform the application is running, it's gonna read well where the event happened. What I mean, the event is when, for example, if it's Unity, where the user clicked, or if it's in iOS or Android, where the user touched. I'm splitting that there because iOS and Android have different ways of handling the touches. So if an icon was touched, we make a zoom to that icon. Then if we actually hit a icon, then we're gonna call the setDescription method. It takes the name of the panel, and then it sets based on that name, it looks in the dictionary what description is for that name, and then it looks for that object name with the name of the panel, and then sets the description with the text retrieved from the dictionary. For the deployment diagram, we have here in the presentation tier, we have both their iOS and Android version. Afterwards, in the application tier, we have the game manager, which is a game object in Unity that is actually holding all the scripts that control the application. And in the data tier, we have the file system, which is where we store all the descriptions. Finally, as you can see here, we use a 3-tier architecture pattern in order to build our application. For testing our application, we use the nsubstitute library. The first test case we implemented was verify that the dictionary is populated with the right data. This dictionary is an object in the description class, which gets populated when the program starts. It goes and loads the data from the text file to this dictionary object. So as a precondition, the file with the description and name of the panel must exist. If this file doesn't exist, then the program, the test is gonna fail. Then the input was the address of the description file, and the expected output was that the dictionary was it's actually populated with the right data. A second test case we implemented was to verify that the description is properly set to the panel. So as a precondition, the user must be in the icon state, and the dictionary is actually populated with data already loaded or previously loaded from the text file. The input is that the user touches the diagram bottom. Then the expected output is that the description of the panel is properly set according to the name of that panel, because the dictionary has the name of the panel and then its description. The previous test cases were unit testing test cases, as its name indicates. These ones are ST, system testing test cases. The first one is it's a sunny day test case, which verifies that the description is properly set to the panel. The precondition is that the user clicks on the icon of the model. Next, the input is that the user touches the diagram bottom, so the expected output is that the description of the panel is properly set according to the name of that panel. The second test case is a rainy day test case, which is going to verify that the description is not set to the panel. The precondition is that the user has clicked on the icon of the model, and the input is that the user touches the movie bottom. The expected output is that the video starts playing and no description was set. And then we're gonna have a demo of the application. So we click here in the scope bottom, a small description of how the application should be used. We choose the point A, and then we calibrate, and then we can see here the 3D model. When we lock with the real video, we click lock, and then now we click mechanical. So we can see the actual structure. If you click here this icon, we're gonna see the movie diagram. We can actually move the cell phone to see. We click here in diagram, we see a small description loaded. We click movie, we're gonna see a movie, but because I'm actually the recording program I was used didn't allow me to reproduce a video and capture it. Then we can move from one point to another icon, click it, see a description. Here again, we go back. We click in the icon to go a lot more back. So here we see another description slab. We can see how the toggle camera works. The camera is not capturing any more video. And we toggle again the camera, and this time we toggle the gyroscope, and then the model is not moving anymore. We hit back, mechanical again, and then you can see how the model stays in place. Thank you so much for watching.